Very good afternoon, student. Today, let us start the physics class from your acoustics lesson. The topic is reflection of sound. Reflection of sound. When you speak in an empty room, you hear a soft repetition of your voice. This is nothing but the reflection of sound waves that you produce. Let us discuss about the reflection of sound in detail through the following activity. A person standing nearby the rigid wall. The person which is produce a sound. The sound waves are incident on the rigid wall and reflected by the rigid wall. When a sound waves travel in a given medium and strike the surface of another medium, they can be bounced back into the first medium. This phenomenon is known as reflection. So this is the 2-mark question. Reflection is nothing but when a sound waves travel in a given medium and strike the surface of the another medium, they can be bounced back into the first medium. This phenomenon is known as reflection. So this is very important point for your 2-mark question. Just highlight this definition. Listen carefully, student. You can read this definition. When a sound waves travel in a given medium and strike the surface of another medium, they can be bounced back into the first medium. This phenomenon is known as reflection. In simple, the reflection and refraction of sound is actually similar to the reflection of light. Thus, the bouncing of sound waves from the interface between two media is termed as the reflection of sound. The waves that strike the interface are termed as the incident wave, and the waves that bounce back are termed as the reflected waves, as shown this figure. Law of reflection. This is law of reflection. Very important 2-mark question. Like light waves, sound waves also obey some fundamental laws of reflection. The following 2 laws of reflections are applicable to sound waves as well. First law, the incident wave the normal to the reflection surface. Here this is the normal line drawn from the barrier, this rigid wall. Perpendicular direction. Normal means perpendicular direction between the wall and the line. So the incident wave, the normal to the reflecting surface, and the reflected wave at the point of incident lie in the same plane. So here this is the incident wave, this is reflected wave. Both the waves are lying in the same plane. So incident wave, this line is indicated the incident ray. The incident wave, the normal to the reflecting surface. This is the normal to the reflecting surface, and the reflected wave. This is reflected wave at the point of incident. Here this is at the point of incidence, lie in the same plane. So both the waves are lying in the same plane. Second statement, that is the second law of reflection, the angle of incidence. angle I is equal to the angle of reflection. This is very easy. Angle of incident is equal to the angle of reflection. Angle I is equal to angle R. The next, the above figure, this figure, the sound waves that travel towards to the reflecting surface are called the incident wave. This is the incident wave. Travel towards to the reflecting surface are called incident wave. The sound waves bouncing back here, this green color line, bouncing back from the reflecting surface are called reflected waves. For all practical purpose, the point of incident, this is the point of incident and the point of reflection is the same point on the reflecting surface. This is same point. Incident point and reflecting point. Point of incident, point of reflection. The same point. A perpendicular line, here this is a perpendicular line, is called normal. Perpendicular line drawn at the point, this point of incident is called the normal. This point is very important. What is meant by normal? Normal means a perpendicular line drawn at the point of incidence is called the normal. The angle which, here this is the angle which the incident sound makes with normal is called angle of incident. The angle which the incident sound waves makes with normal is called the angle of incidence. Then it is represent I. Angle of incidence is represent I. The angle which the reflected waves makes with the normal, this is normal. Normal is called angle of reflection. This represent small r. The angle which the reflected waves makes with the normal is called the angle of reflection. This represents small r. Next topic is reflection at the boundary of a denser medium. Reflection at the boundary of a denser medium. A longitudinal wave travel in a medium. This is a longitudinal wave traveling in a medium. Form of compression. This area is nothing but compression and this is rarefaction. Compression and rarefaction. Suppose a compression traveling in air from left to right reaches a rigid wall. Rigid means it does not change the shape and the size when an external force applied on it. So rigid wall, left to right. So compression traveling in air from left to right reaches a rigid wall. The compression exerts a force F on the rigid wall. In turn, the wall exerted an equal opposite reaction. That means capital R is nothing but reaction is equal to minus F. Because reaction always opposite to the applied force on the air molecules. This result in a compression near the rigid wall, here this place near the rigid wall. Thus a compression traveling towards the rigid wall is reflected back as a compression. So compression traveling towards the rigid wall also compression state. Then reflected back, wall is reflected back as a compression state. That is the direction of compression is reversed. The next, reflection at a boundary of a rarer medium. Reflection at a boundary of a rarer medium. Consider a wave traveling in a solid medium striking on the interface between the solid and the air. The compression exerts a force F on the surface of rarer medium. As a rarer medium has smaller resistance for any deformation. The surface of, this is very very important point for your objective type question, please note it down children. As a rarer medium has a smaller resistance for any deformation. The surface of separation is pushed backward. By this figure, we can easily understand this statement. As the particles of the rarer medium are free to move, a rare fraction is produced at the interface. Thus, the compression is reflected as a rare fraction, and a rare fraction travels from right to left. The next topic is reflection of sound in plane and curved surface. Reflection of sound in plane and curved surface. When a sound waves are reflected from a plane surface, the sound reflected waves travel in a direction according to the law of reflection. So, reflected wave from a plane surface obey the law of reflection. The intensity, what is the law of reflection? Incident angle is equal to the reflection angle. Then incident ray and reflected ray lying in the same plane. So, this reflection of sound in plane and the curved surface obey the law of reflection. The intensity of the reflected wave is neither decreased nor increased. The intensity of the reflected wave is neither decreased nor increased. So, this is very very important point. Please note it down children. The intensity of the reflected wave is neither decreased nor increased. But when the sound waves are reflected from the curved surface, the intensity of reflected wave is changed. This point also very important point. Please note it down. When the sound waves are reflected from the curved surface, the intensity of the reflected wave is changed. This is important objective type question. Please note it down. When reflected from a concave surface, this is also very very important paragraph for your objective type. When reflected from a convex surface, the reflected waves are diverged out and the intensity is decreased. So, the wave reflected by the convex surface means the intensity of sound is decreased. When sound is reflected from the concave surface, the reflected waves are converged and focused at a point. So, the intensity of reflected wave is concentrated at a point. So, that is why the intensity is increased. What is meant by convex surface? What is meant by concave surface? Convex surface means thicker in middle, thinner in edges. So, middle point is thicker and the edge point thicker in middle, thinner in edges. Edge point is it shows the thinner surface. What is meant by concave surface? Thinner in middle and thicker in edges. It is concave surface. So, when the sound is reflected from a concave surface, the reflected waves are converged and focused at a point. Because thinner in middle, thicker in edges means all the sound waves focused at one point. So, the intensity of reflected wave is concentrated at a point. Parabolic surface are used when it is required to focus the sound at a particular point. Hence, many halls are designed with parabolic reflecting surfaces. In elliptical surfaces, sound from one focus will always be reflected to the other focus, no matter where it strikes the wall. So, this paragraph is very important for your objective type. The intensity of, once again repeat, the intensity of the reflected wave is neither decreased nor increased. When the sound waves are reflected from the curved surface, the intensity of the reflected wave is changed. If suppose the reflected surface is a convex surface, means the reflected waves are diverged out and the intensity is decreased. Maybe the reflected surface we can consider as the concave surface, means the reflected waves are converged and focused at a point. So that is why the intensity of sound is increased. The next, the principle is used in designing which the halls in a whispering gallery. This principle is used in designing whispering halls. In a whispering halls, the speech of a person in one focus can be heard clearly by a listener standing at the other focus. The next, echoes. Next topic is echoes. Echo. An echo is the sound reproduced due to the reflection of the original sound from various rigid surfaces such as walls, ceiling, surfaces of mountains, etc. So this point is a very important question. 2 more question. Please note it down, children. An echo is the sound reproduced due to the reflections of the original sound from various rigid surfaces such as walls, ceilings, surfaces of mountain, etc. If you shout or clap near the mountain or near a reflecting surface, what happens? Like a building, you can hear the same sound again. The sound which you heard is called an echo. It is due to the reflections of sound. One does not experience any echo sound in a small room. This does not mean that sound is not reflected in a small room. This is because smaller rooms do not satisfy the basic condition for hearing an echo. So this is also very important objective type point. Please note it down. Small room, one does not experience any echo sound in a small room. This does not mean that a sound is not reflected in a small room. This is because smaller rooms do not satisfy the basic conditions for the hearing an echo. So this point also very important point. The next, conditions necessary for the hearing echo. Conditions necessary for hearing echo. This topic also very important topic for your problem question as well as the objective type question. The persistence of hearing for human ears is 0.1 second. So this is very important point. Please note it down, children. The persistence of hearing for human ears is 0.1 second. This means that you can hear the two sound waves clearly if the time interval between the two sounds is at least 0.1 second. Thus, the minimum time gap between the original sound and echo must be 0.1 second. This point also very important point. Please note it down, children. Listen carefully. That minimum time gap between the original sound and an echo must be 0.1 second. The above criterion can be satisfied only when the distance between the source of sound and the reflecting surface would satisfy the following equation. So what is the formula for velocity? Velocity is equal to distance traveled by sound by time taken. This point also very important. This is important formulas. Velocity is equal to distance traveled by sound divided by time taken. So formula is V is equal to 2D divided by T. Rearrange this equation. D is equal to this T term goes to left hand side, means it will move to numerator side. So Vt divided by this 2 term, the number 2 goes to left hand side, means this is moved towards to denominator. So that is why D is equal to Vt divided by 2. Since time T is equal to 0.1, just substituting the value of time, we obtain V into 0.1 divided by 2. That means V divided by 20, because 0.1 can be written as 10 power minus 1. 1 into 10 power minus 1. 10 power minus 1 moves towards to denominator term. So 10 power minus 1 became a 10 power plus 1. 2 into 10, 20. So V divided by 20. Thus the minimum distance required to hear an echo is 1 by 20th part of the magnitude. This point is very important point. Please note it down. The minimum distance required to hear an echo is 1 by 20th. Very important point, children. Please note it down. 1 by 20th part of the magnitude of the velocity of sound in air. The condition is in air. The next point also very important point for your objective type question. If you consider the velocity of sound as 344 meter per second. Here, if you consider the velocity of sound as 344 meter per second, the minimum distance required to hear an echo is 17.2 seconds. 17.2 seconds. So here the minimum distance required to hear an echo is 17.2 seconds. Is 17.2 seconds. So please note it down, children. 344 meter per second is the velocity of sound. 17.2 is the hearing echo. The next important topic is applications of echo. Applications of echo. Some animals communicate with each other over long distance and also located objects by sending the sound signals and receiving the echo as reflected from the target. The second point is the principle of echo is used in obstetric ultrasonography, which is used to create real-time visual images of the developing embryo or fetus in the mother's uterus. This is a safe testing tool as it does not use any harmful radiation. Then third application is echo is used to determine the velocity of sound wave in any medium. So this point is very important. Echo is used to determine the velocity of sound waves in any medium. So very important points. This is very important. 2 more question as well as the objective question. Applications of echo. The next important topic is measuring velocity of sound. Echo with method. In echo method, apparatus required. A source of sound pulses, a measuring tapes, a sound receiver, and a stopwatch. So what are the apparatus required for the measuring velocity of sound? A source of sound pulses, a measuring tape, a sound receiver, and a stopwatch. Procedure is, first point, measure the distance d between the source of sound pulse and the reflecting surface using the measuring tape. Second point is, the receiver is also placed adjacent to the source. A sound pulse is emitted by the source. Third point is that stopwatch is used to note the time interval between the instant at which the sound pulse is sent and the instant at which the echo is received by the receiver. Note that time interval as t by the help of the stopwatch. Then the fourth point is, repeat the experiment for 3 or 4 times. The average time taken for the given number of pulses is calculated. So these are all the 4 points is the procedure of measuring velocity of sound by echo method. Then the calculation of speed of sound. This is very important topic. Calculation of speed of sound. This topic is very important for your 2-mark problem. The sound pulse emitted by the source traveling at a distance of 2d while traveling from the source to the wall and the back to the receiver. The time taken for this has been observed to be t. Hence, the speed of sound waves is given by speed of sound. This formula is very important point. Speed of sound is equal to distance traveled by time taken is equal to 2d divided by t. Then applications reflection of sound. Applications of reflection of sound. First application is soundboard. These are basically curved surface, concave. Concave means thinner in middle, thicker in edges, which are used in auditoria and halls to improve the quality of sound. This board is placed such that the speaker is at the focus of the concave surface. So this board is placed such that the speaker is at the focus of the concave surface. The sound of the speaker is reflected towards the audience, thus improving the quality of sound heard by the audience. So, improving the quality of sound heard by the audience. This is the uses of reflection of sound by the soundboard. Then the second application is ear trumpet. Ear trumpet is a hearing aid which is useful by people who have difficulty in hearing. In this device, one end is wide and the other end is narrow. So this point is very important point, children. Please note it down. One end is wide and the other end is narrow. The sound from the source fall into the wide end and are reflected by its walls into the narrow part of the device. This helps in concentrating the sound and the sound enters the eardrum with more intensity. So this is also very important point. Eardrum with more intensity. This enables a person to hear the sound better. Then the last use is megaphone. Its short form of megaphone is nothing but megaphone. A megaphone is a horn-shaped device used to small gatherings of people. Its one end is wide and the other end is narrow. When a person speaks at the narrow end, the sound of his speech is concentrated by the multiple reflections from the walls of the tube. Thus, his voice can be heard loudly over a long distance. So this is very important point. His voice can be heard loudly over a long distance by using the megaphone. This is also one application for reflection of sound. So from this topic, very important points are, once again repeat, important points. What is mean by reflection? Reflection means when a sound waves are traveling in a given medium and strike the surface of another medium, they can be bounced back into the first medium. This phenomenon is known as deflection. The next, law of reflection. This is also important 2 mark question, children. Please note it down. The incident wave, the normal to the reflecting surface and the reflected wave at the point of incident lie in the same plane. Second law is the angle of incident is equal to the angle of reflection. This is also important 2 mark question. Then next important point is a perpendicular line drawn at the point of incident is called as the normal. What is meant by normal line means a perpendicular line drawn at the point of incident is called normal. The angle which the incident sound wave makes with the normal is called the angle of incident, I. The angle which the reflected wave makes with the normal is called the angle of reflection. It is represented by R. So, what is meant by angle of incident? The angle which the incident sound wave makes with the normal is called angle of incident. It is represented by I. What is meant by angle of reflection? The angle which the reflected wave makes with the normal is called the angle of reflection. It is represented small r. Then the next important point is, as a rarer medium has a smaller resistance for any deformation, the surface of separation is pushed back. Next important point is, the intensity of the reflected wave is neither decreases or nor increased. The intensity of the reflected wave is neither decreased nor increased. When the sound waves are reflected from the curved surface, the intensity of the reflected wave is changed. The next important point is, when reflected from a convex surface, the reflected waves are diverged out and the intensity is decreased. When sound is reflected from the concave surface, the reflected waves are converged and focused at a point, so the intensity of sound is increased. So the intensity of reflected wave is concentrated at a point. The next important point is, what is meant by echoes? Echoes, an echo is the sound reproduced due to the reflection of the original sound from various rigid surface such as wall, ceiling, surface of mountain, etc. So this is the definition of echoes. This is 2 mark question, children. Note it down. Then next important point of echo is, one does not experience any echo sound in small room. This does not mean that sound is not reflected in a small room. This is because smaller rooms do not satisfy the basic condition for hearing an echo. The next important thing is, the persistence of hearing for human ears is 0.1 second. The minimum gap between the original sound and an echo must be 0.1 second. The next important point is, the minimum distance required to hear an echo is 1/20th part of the magnitude of the velocity of sound in air. Then second important point is, if you consider the velocity of sound as 344 meter per second in air, then the minimum speed required to hearing the echo is 17.2 meter. Minimum distance required to hearing the echo is nothing but 17.2 meter. This is an important objective type point. Children, please note it down. Then application, one important application, echo is used to determine the velocity of sound wave in any medium. So these are all the important points. Applications of reflection sound topic. Hearing trumpet, one end is wide and the other end is narrow. Ear drum with more intensity. So these are all the important points, children. Thank you very much.